So I will keep you updated with announcements, of course, as the week continues. Just so that you know, there's a full week of school this week. Next week, we have school Monday and Tuesday only. Okay, you don't have classes next week on Wednesday, Thursday, or Friday. It's Thanksgiving break. So I will be holding classes as usual next week on Monday and Tuesday. If some of you already have plans to go home beforehand, well, you can Zoom. So that's the beauty of having the Zoom option, I suppose. So that's the deal with next week. There's one slight change to this week. And that is that we have class as usual, Monday, Tuesday, Wednesday. Thursday, we don't have class. And I need to be in Bozeman. I'm leaving for Bozeman Wednesday, mid-afternoon. And we'll be gone for the rest of the week. So what I'm going to do instead of class is I am going to record a video, and I am of me teaching. So if all you do is access the box folder for this class, it's going to be no different for you. I'll just be talking to myself at the time, but I'll sit in my office and make a video, post the video. I will then also post the notes. And I will also make our next in-class worksheet active as well. I'm probably just gonna have that worksheet due the Monday after Thanksgiving, just to give everybody sufficient time. But I'll be very clear in my email message, in my weekly email, about what the plan is. And in that email, I'll also have the video and the notes both linked into that email if you don't want to have to jump into the entire box folder. But that's a way to keep us up to date and for me to know what's covered, et cetera, et cetera. So on Friday of this week, you don't have to tune in at 10 o'clock. And you will just have a video to watch. And then of course, the following Monday, I'll answer any and all questions and clarify anything. Is that okay? Cool. I will be doing a presentation at 10 o'clock on Friday morning, but not a fun math one. So, but it's about math. Anyway. Sally, that's a great question. My plan is to finish up lesson 12 today. So it'll be due a week from today. And I'll keep everybody posted with all the announcements as well. Okay. Last but not least, I have all of your papers here. If anyone wants their test back, or even if you don't want your test back, I want to give it back to you. You know, as you come to class, please be sure you pick that up. Sound good? Okay. You ready to jump in and do math? You all seem a little less than enthused. Is it just a Monday morning thing? Yeah, okay. Well, if there's anything that will get your excitement up, we're going to talk about it. All righty. So you may or may not recall that we have been talking about lesson 12, and I've been spending a fair amount of time on this section, not because I'm going to ask you on the last test to find a ton of different equations of lines, but the techniques in here are important. We're learning these so we can actually take these ideas and apply them The whole purpose for the end portion of this Math 115 class, again, we're done with the probability and statistics. We do this linear portion of the class for the business major. So if you're not a business major, I guess just deal. It's kind of fun math, and I hope to make it as accessible as possible. But again, we offer Math 115 as a service course for all sorts of different majors, and business being one of them. So that's why we do this linear portion at the very end. Okay. So we were talking about the finding equations of lines. We were talking about graphing a line if you're given a point and a slope. And what we have is just a couple tail end ideas to talk about, okay? So one of them discusses parallel lines, okay? So parallel lines have a relationship with each other. Pretend that those are decently drawn parallel lines, okay? Does anyone know what parallel lines might have in common? Good job. Parallel lines have the same slope. They occur in different places in our Cartesian coordinate system, but they do have the same slope. The only difference is they obviously then have a different y-intercept. If they have the same slope and y-intercept, they'd be the same line, okay? So what I would venture to say is walking up this hill would be equivalent to walking up this hill in terms of bodily exertion. On the other hand, we also have perpendicular lines. Now, lines can intersect in a ton of different ways, but when we talk about perpendicular lines, we're talking about a specific type of intersection. Perpendicular lines are ones that meet at a 90-degree angle, okay? That's what this little symbol is. That might take you back to high school geometry, or it might not, as the case may be. A symbol that we use for perpendicular lines is this, because it's a heck of a lot shorter to write this than it is to write out perpendicular lines, okay? Well, perpendicular lines clearly do not have the same slope. If for no other reason, I think you'll grant me that the slope of this line is positive and the slope of this line is negative. As it turns out, what we can say is perpendicular lines have slopes that are opposite reciprocals. Of each other. Now, to a lot of people, that's a mouthful of gibberish, okay? So I want to be pragmatic about things, okay? So if you have the slope of a line and you want to find the slope of the line perpendicular to it, what you do is you change the sign. That's what we mean by opposite. And flip it, which is what we mean by reciprocal. All right, so let's just practice a few of them. For example, suppose you have the slope of a line is 2/3. What I want us to do is write the slope of the line that's perpendicular to it. Well, first thing we do is we change the sign. Since this is positive, this is going to be negative. And what happens when you flip 2/3? You get 3/2. What if I have a line having a slope of let's do -5/7? What's the slope of the line perpendicular to this? 7/5. Thank you. If there's any questions how I'm doing this, please, please, you know, if you're in here, yell out. If you're on Zoom, please stop me. What if I have the slope of a line to be equal to 3? What's the slope of the line perpendicular to it?
Negative 1/3.
Beautiful. Negative 1/3. Good job. Notice we can rewrite any whole number, for example, 3 as 3/1. And therefore, it's going to be negative, and then we're going to flip this. All right, so adding that on, what I want to do is just find a couple more examples of equations of lines, okay? All right, so what if I want us to find the equation of the line with an x-intercept of negative 2/3 that is perpendicular to the line 2x minus y equals 4. This is a big one for a Monday morning, especially a Monday after a 3-day weekend. All right, so notice our instructions are to find the equation of the line. The first thing I tell myself is, okay, if I want to find the equation of the line, I want to find y equals mx plus b. In particular, I need to find my value of m and my value of b. Okay? I claim we are not given either one of those directly. Okay? We do have an ordered pair. Can somebody tell me what my ordered pair is? Well, I have an x-intercept of negative 2/3. Here, why don't I rewrite this so you can actually read it? How would I write that as an ordered pair? Oh, come on. By definition, what is an x-intercept? Isn't it the value of x when y is 0? So first thing we're doing is we're translating what that ordered pair is. Okay, so we have an ordered pair that goes through this line. The thing is, we also need a slope since we're not given another point. Okay, so what are we given? Well, we're not directly given a slope, but aren't we given that our line is perpendicular to this line? So do you agree if we could determine what the slope of this line is, we would then be able to decipher what the slope of our line is? All right, does anyone remember from last week, which seems just like eons ago, what the probably most efficient way of finding the slope of this line is? Well, it's a good thing I'm self-conversationalist. Yeah. You are awesome. Thank you. What we can do is rewrite this as y equals mx plus b, and then we can just read off the slope. Okay? So we want to get y alone on this side. What I can do is subtract 2x from both sides. And now what I need to do is say, well, I don't want negative y, I want y. So we'll multiply or divide by -1, which just changes the sign of everybody. So do you all agree that the slope of this line here is 2? Therefore, what is our slope? Well, change the sign and flip it. What do we get? -1/2. So now we have that y is -1/2 x plus b. Okay, we got one of those two values. So what we now need to do is find the value of b. Well, how can we find b? Plug in our ordered pair. I have the ordered pair, -2/3, 0. So I know y is equal to 0 when x is -2/3. All right, well, we got 0, a negative times a negative is a positive. And multiplying two fractions, you can look at it in a couple different ways. One of it is you can multiply your numerators, multiply your denominators. Another thing you could say is, well, I got a 2 here and I got a 2 here. So I'm going to be left with 1/3 plus b. If there's a question how I got 1/3 here, you've got to ask me now, because pretty soon I'm going to start going through fractions a bit quicker. Yeah, so if I have -1/2 times a -2/3, okay, you could multiply across your numerator and across your denominator, and you're going to get 2/6. But then 2 goes into itself once and into 6 3 times. What I tend to do is if there is something I can simplify before doing the multiplication, I do that. So we can now solve for b by scooting the 1/3 over. We can subtract it from both sides. So we're going to get b is -1/3. So the equation of this line is -1/2 x minus 1/3. Any questions there? All right. Well, let's do another one. Suppose we are given the line y equals -1/4 x minus 5. What I want us to do is find the equation of the line passing through -610 that is parallel to the above line. And then we're going to do part B that is perpendicular. Doesn't this look like fun? All right. Well, what do we know about parallel lines? Horizontal lines do have a 0 slope. Absolutely. Parallel lines have the same slope. Right on. You're awesome. Okay. So we know the slope of this line. And since parallel lines have the same slope, we also know the slope of the line we're looking for. Ooh, it's probably this thing. I need to get a new cord. Is that better, Sally? Oh yeah, I like your pun. Let's see if this works better. I have to get a new connection cord. Cool. I'm just holding up my bundle of cord up here. Okay, well, we need to find B. How do we find B? We plug in the ordered pair that we're given. You agree we can say, well, y is 10 when x is -6? All right. Well, again, we can multiply across. We multiply our numerators, we get 6. We multiply our denominators, we get 4. I like to simplify my fractions. So I would put 3/2. Okay, if you want to put 1.5, that's also just fine. Do you all have a preference whether I use a fraction or a decimal? I could care less, so I'd rather do what you prefer. Fraction? Okay, so I have 3/2 plus B. Okay, well, what we want to do now is solve for B. How do I move the 3/2 over? I subtract it from both sides. So I'm going to get B is equal to 10 minus 3/2. Now, if fractions vibe you out, just put this in your calculator, okay? You can put this in your calculator and you're going to get a nice decimal number. If you like fractions, what we need to find is a common denominator, okay? How can I rewrite 10 with a common denominator of 2? Well, that would be 20/2 minus 3/2. So don't we get 17/2? If you used a calculator, you're just going to get this to be 8.5. It's the same thing. Should you freak out because you're getting fractions? All over the place, friends. Can't bake banana bread without them. I know. I tend to do that. And then I get a really good arm workout because I'm trying to stir really thick batter. All right. Questions on this? Okay. Now let's do the perpendicular. Well, if our line is perpendicular to this line, what's the slope of our line? 4. Good. If there's any questions, I want you to ask. We need to find B. So how can we do it? We can, again, plug in our ordered pair. We can say 10 is 4 times -6 plus B. So 10 is -24 plus B. And to find B, we can add 24 to both sides. And that will give us 34 equals B. And we get our line. Questions there? Okay. I'm going to change things just a little bit. What? Okay. Let's do this. most of the reason why we talk about finding equations of lines is there's a fair amount of things in the real world that can be modeled using linear equations. There's a fair number of things in the real world that cannot, but we are going to talk about applications in the quote unquote real world. Okay. So what I want you to recall, and we're only going to be doing applications that involve lines. When we have the equation of a line, this value of B we know is our y-intercept, okay? In other words, it's the value of y when x is equal to 0. A lot of times we think of that as our initial value, okay? Because x is our variable. Our slope is m. Okay, we know that our slope is the ratio of rise over run. In other words, it's the change in y values over the change in x values. What I want to get across is that our slope is a rate of change. Okay, so for example, we talk about rates of change fairly frequently if we're thinking about driving a vehicle. Right? We can talk about our speed, miles per hour. That's a rate of change. We can talk about how fuel efficient our car is by talking about how many miles per gallon we get. We can talk about how expensive gas is by looking at the rate of change of dollars per gallon. Okay, whenever you have that per, we've got a rate of change going on. Okay. So we're going to be going through a lot of applications in the next section. What I want us to do is just do a few warm-ups here. Okay, so suppose you need to move. Hence, rent a truck. Suppose the cost for the rental, well, this is a ripoff, is $40 plus 25 cents per mile driven. What I'm going to do is I'm going to tell us, let's let X stand for the number of miles driven, and I'm going to let Y represent my total cost in dollars. Once we get into word problems, we're extraordinarily particular about our units. All right, I claim we can find the equation of this line, okay? Do you all agree that, well, number one, we're given a rate of change, aren't we? Okay, what is the variable changing? What we want to do is find y equals mx plus b. Well, what do we know here? What happens if I drive 0 miles? Will I still have to pay something? Yeah, just to rent the truck and hang out in the parking lot is going to cost me $40. I don't have to go anywhere. Okay. So do you all agree that when we drive 0 miles, it's still going to cost us $40? Okay, so that gives me my B value. We can say when X is equal to 0, we have Y is 40. Do we know the slope? Well, the slope is the rate of change. Let's talk about the units for this rate of change. If my rate of change is the change in Y values over the change in X values, notice my Y values are dollars and my X value are miles. Well, how much are we adding on for each mile we drive? We're adding on 25 cents. So we're going to put 0.25x plus 40. Notice you need to keep your units the same. Since this was in dollars, you need this in dollars. Any questions there? So suppose I drive, I don't know, 10 miles. What is my total cost? Can I find that? Absolutely. Notice we have two unknowns. X stands for miles, Y stands for cost. We're given one, we want to find the other. What are we given, X or Y? X, good. So I have 0.25 times 10 plus 40. So that gives me 2.5 plus 40, or this whole thing is going to cost me $42.50. Okay. Now, suppose on the other hand, you're in this scenario to rent a truck, and this is the formula for the cost of the rental. But suppose you say, I only have $200 to spend on the rental. How many miles can I go? Not an unreasonable question. I think that most of us in life at some point or another are bound by a certain amount of money we have. Okay. Well, I claim this is a similar situation. Notice here, though, I'm given $200 and I want to find the number of miles. In other words, I want to find X. Can I do that? Totally. You plug 200 in for Y. And now we solve for X. What would be my first step in solving for X? Good. We'd first subtract 40 from both sides. So we're going to get 160 is 0.25X. Good job. We want to get X alone. The problem is we're multiplying by 0.25, and the way you undo multiplication is division. We divide both sides by 0.25, and you should get 640 miles. Wow, that's a lot of miles. Well, you might as well have some sort of random emotion about the stupid word problem, right? Questions there? All right. Now what I'm going to do is I'm going to give you an equation, and what we're going to do is we're going to interpret the meaning of our slope and our y-intercept. I do ask you to do this in this class, okay? I mean, it's one thing to be able to do like kind of the cookbook, find the equation of the line thing, but it's also really important to be able to interpret what it is we're working with. So I'm going to suppose I'm going to write V of X. That's my value, and my variable is X. You can think of this as the same as Y. Is negative 1.75X plus 4,000. Or not, take out the decimal. Let's just have negative 175X. Suppose I'm going to tell you that X stands for the number of years since the purchase, and V is the value of my washing machine in dollars. So essentially what I'm saying is this linear equation represents the value in dollars of the washing machine. Okay, X number of years after we purchased it. So let me ask you this. What was the cost, the initial cost of the washing machine? It sure is $4,000. If X stands for the number of years since the purchase, okay, then when you have X equals 0, that's the year that we purchased it. That's our initial value, okay? So again, this is just me laying out how to interpret that initial value. Now, what if I want us to interpret the slope? Well, what is my slope numerically? It's -175. I always recommend you think about the units. That helps with the interpretation. Remember, the units are the change in your Y values over the change in your X values. Our Y values are in dollars, and our X value is in years. So how can we interpret -175 in terms of this particular washing machine? Well, is it increasing in value or is it decreasing in value? It's decreasing in value. Good. How do you know? Because it's negative. So what we can say is that the value decreases on average $175 per year. You with me there? Don't worry. You're going to get a lot of practice in lesson 14 with interpreting. Okay. This section is kind of the skills building section. In the next section, we're going to do word problems. And then in the section after that, we'll be doing a bunch of interpreting. Okay, but this is the math skills section. So suppose this is my washing machine. And I want to know, when will the washing machine be worth nothing using this model? I mean, clearly you can always get scrap metal price for it, so. Well, notice I want to know when. So what am I looking for? X or V? X, good, because that's what represents time. Well, I want to know when, so I want to find X. What is the value of V that I'm looking for? Well, what's the value if it's worth nothing? 0. Can we solve this? One hopes. What would you do? Good, you want to get your X all by its lonesome so we can move the 4,000 over by subtracting it from both sides. So we have -4,000 is -175x. But I don't want -175x, I want X. How do you undo multiplication? Division, divide both sides by negative 175. So you're going to get about 22.9. So I would round and just say, well, about 23 years later. And given the way things are made these days, good luck getting a washing machine to last for 23 years. Just saying. Are you having fun yet? All right, I'm going to do one more example just to tie things together. And I'm doing this because of a question that I asked at the beginning of class and people hesitated. I just want to be sure you're all cool with this. Suppose I have negative 3x plus 5y equals 15. Okay. One of the things that we did last week was we would take an equation of a line in this general or standard form and put it in the y equals mx plus b. And the reason for doing that was, wow, once you have it solved for y, you can read off your slope and you can read off your y-intercept. Okay, that's the really sweet thing about having a line solved for y. Now, suppose you're given a line in this form, and what I want us to do instead is find the x and y intercepts. Well, we can totally do this. Okay, this is important. Intercepts turn out to be a really useful thing to look for later. With application problems. Okay, now you may or may not recall how to do this, which is why I kind of wanted to piggyback around and make sure we go through an example here. So by definition, your x-intercept is the value of x when y is 0. So recall, to find it, you set y equal to 0 and solve for x. Okay, so I'm going to put in y equals 0. Now, in my mind, you really don't need to show much work here. I'm going to show the work just to be sure that we're all on the same page. Okay, but you know, if plugging 0 in is fluid for you, right? Because when you plug 0 in, what happens to this entire term? Well, what's anything times 0? It just goes away. That's the beautiful thing about 0. So I can say negative 3 times x plus 5 times 0 is 15. Well, again, this is 0. So I get negative 3x is 15. So what does my x-intercept equal to? Negative 5. So as an ordered pair, we would write that as negative 5, 0. I very intentionally made our numbers nice. What if now we want to find the y-intercept? How would we find the y-intercept? Well, by definition, it's the value of y when x is 0. So we'll do the same thing. But now we'll set x equal to 0 and we'll solve for y. Again, if you plug 0 in, it just nixes this term entirely, okay? But I'll show every step. Negative 3 times 0 plus 5y is 15. So we're solving 5y equals 15. Divide both sides by 5 and we get y to be 3. So my y-intercept as an ordered pair is 0, 3. All right. So what I want to do now in the short amount of time that we have left is share my screen. And I just want to mention here real quick, I have 4 minutes, so I want to use them. Notice There's a bunch of short video lessons if you would find those to be helpful. But what I need to do is set the due date, and it will be due a week from today. I want to just point something out before you all split. So today's the 14th, so it'll be due the 21st, next week on Monday. All right, what I want to show you in your online homework is as follows. Question 1, you're given 2 ordered pairs and you just want to find the slope of the line. Okay, here in question number 2, you want to find the slopes of these lines. Hopefully you remember the slope of a vertical line and the slope of a horizontal line. If not, you can certainly take 2 ordered pairs on this line and find the slope. For this one, you could do it a couple different ways. You could take 2 ordered pairs and use the formula, or you could take 2 ordered pairs and just talk about what your rise over run is. So for example, with my example here, to get from this ordered pair to this ordered pair, don't we rise 1 and run 2? So my slope would be 1/2. Either way you do it, it's totally cool. Here you want to write the equation of the line. Notice you're given your slope and a very nifty point. Don't work harder than you need to. For this one, this is just practicing finding the equations of lines. Again, on your test, you're not going to have a bunch of these, but if you get all the practice out here, you're smooth sailing mathematically, okay? So you're given points and slopes and you want to find the corresponding equations. Here's another find the equation of a line with the particular point and slope. Oh, look, here you're finding the intercepts. We just did that. And then you get to graph it. And another one of finding intercepts. And another one. And then here are parallel and perpendicular. And then this gives you a graph of a line, and I want you to tell me what the y-intercept is. I want you to tell me what the slope is, and then write the equation. Okay? So tomorrow we are going to jump into lesson 13. Do not wait until the weekend to do lesson 12, because we're going to be using all of these techniques to find the equations of lines as we proceed through the next lesson. All right, friends, I hope you have a great day.